Hello students, this is my second lecture on chemical calculations. Today I will show how you can calculate moles mass for solid substance. You know, solid substance masses have mass say gram, kg or ton. If gram, kg or ton is given on question, we will apply solid formula. Calculation of moles and mass for solid substance. You know, solid substance have gram, kg or ton. Solid substance. Let's move. This formula 1 first. For solid substance, mass in gram divided by molar mass or molecular mass. Number of mole equal mass in gram divided by molar mass or molecular mass. So mass will be cross multiplication number of mole times molar mass or molecular mass. Mass equal number of mole times molar mass or molecular mass. So now problem 1. Calculate the number of moles of 10.6 gram of sodium carbonate. Calculate the number of moles of 10.6 gram of sodium carbonate. This is the sodium carbonate. 10.6 gram is given. So we will apply solid formula because solid substance measure as gram, kg or ton. First MR. MR means relative molecular mass. Relative molecular mass of sodium carbonate. Here 2 sodium atom, 23 times 2. Sodium relative atomic mass is 2. Carbon plus carbon 12. Here 3 oxygen atom. Oxygen 16 into 3. You will get 106 relative molecular mass. Now moles of sodium carbonate mass in gram divided by molar mass or molecular mass. Mass in gram 10.6 gram is given. Molecular mass you calculate 106. So moles of sodium carbonate will be 0.1 moles. This is the moles of sodium carbonate. Now problem 2. Calculate the number of moles of 9 gram of water. Here also water mass is given. First MR relative molecular mass of water. Here 2 hydrogen 1 times 2 1 oxygen plus 16. If you add relative atomic masses, you will get relative molecular mass or relative molar mass. Then moles of water, solid formula, mass in gram is given 9. You write here 9 divided by molar mass. You calculate here, I calculate here 18, so you write here 18. Then we get 0.05 moles of water. Come to next problem, problem 3. Calculate the number of moles of 8 gram of methane. CH4, his name is methane. Methane mass is given. So at first you calculate relative molar mass of methane. Carbon relative atomic mass is 12 plus 1 times 4. There are 4 hydrogen atom. You will get 16. Now formula, moles of methane or number of moles of methane equal mass in gram divided by molecular mass, 0.5 moles. Okay. Now problem 4. Calculate the mass. Now question is asking to calculate mass. Mass of 0.5 moles. Here moles is given. We have to calculate mass of sodium carbonate. You know, mass equal number of moles into molar mass or molecular mass. Mass equal number of moles times molar mass or molecular mass. So number of moles is given 0.05. Molar mass I calculate here relative, MR means relative molar mass of sodium carbonate. Here 2 sodium atom, 23 times 2, 1 carbon plus 12, oxygen 16 times 3. Relative atomic mass of oxygen is 16, so here 3 oxygen atom, 106. Now molar mass 106. If you multiply, you will get 53 gram. 53 gram. Mass equal number of moles is given. Molecular mass or molar mass I calculate here. So if you calculate 0.05 times 106, you will get 53 gram. Mass equal number of mole into molar mass. Come to next problem. Problem 5. When sodium carbonate, this is the sodium carbonate, is added to magnesium chloride, this is the magnesium chloride, the reaction that occurs is given below. Sodium carbonate reacts with magnesium chloride to produce sodium chloride and magnesium carbonate. Sodium carbonate reacts with magnesium chloride to produce sodium chloride plus magnesium carbonate. You know, this is the reactant, this is the products. And now mole ratio. Here no number means 1 mole. 1 mole sodium carbonate reacts with 1 mole magnesium chloride to produce here 2 mole of sodium chloride plus 1 mole of magnesium carbonate. Now question is asking you, calculate the mass of sodium carbonate. This is the sodium carbonate needed to make exactly 3.36 gram of magnesium carbonate. I mean, magnesium carbonate 3.36 gram is given. Mass of sodium carbonate what? This is the asking question. 3.36 gram magnesium carbonate. How much sodium carbonate is needed? As in question gram is given, so we will apply solid formula. First, relative molecular mass of magnesium carbonate. Magnesium relative atomic mass 24 you will get from periodic table. Carbon 12, oxygen 16 times 3 because here there are 3 oxygen atom. You will get 84 relative molecular mass of magnesium carbonate. Then relative molecular mass of sodium carbonate. Sodium 23 times 2 plus carbon 12 plus oxygen 16 times 3, you will get 106. So moles of magnesium carbonate, mass of magnesium carbonate, this is given, divided by molar mass or molecular mass. 3.36 is given here. Molar mass of magnesium carbonate I calculate here 84. So we get 0.04 moles of magnesium carbonate. Now you see mole ratio is same. Magnesium carbonate is 1 mole, sodium carbonate also 1 mole. I mean their mole ratio equal. So mole ratio magnesium carbonate ratio sodium carbonate 1:1. How we get it? Here 1, here 1. I mean moles of magnesium carbonate will be equal to moles of sodium carbonate. I calculate here magnesium carbonate mole 0.04 moles. So moles of sodium carbonate will be same 0.04 because their mole ratio is 1:1. Their mole ratio equal. Now mass of sodium carbonate will be number of mole times molar mass. Mass of sodium carbonate will be number of mole times molecular mass. Number of moles we get here 0.04 times molar mass of sodium carbonate 106. If you calculate, you get this value 4.24 gram. Okay. Moles of magnesium carbonate, mass in gram divided by molecular mass. Mass given, molecular mass I calculate here. So we get moles of 0.04. Now magnesium carbonate number of mole and sodium carbonate number of mole are equal, 1:1. So moles of sodium carbonate will be same as magnesium carbonate. Moles of sodium carbonate will be equal moles of magnesium carbonate. Then mass of sodium carbonate equal number of mole of sodium carbonate into molar mass. 0.04 times 106, we get 4.24 gram. Come to next problem now. Problem 6. What mass of sodium sulfate, this is the sodium sulfate, what mass of sodium sulfate would be produced from when 5 gram of sodium hydroxide, here sodium hydroxide is NaOH, 5 gram is given, with excess sulfuric acid. Question is asking you, when 5 gram of sodium hydroxide react with excess sulfuric acid, what mass of sodium sulfate will be produced? As 5 gram of sodium hydroxide is given, so gram is the unit of solid, we use solid formula. If mass as gram, kg or ton is given, we will apply solid formula. So moles of sodium hydroxide or number of moles of sodium hydroxide, mass of sodium hydroxide divided by molecular mass of sodium hydroxide. Sodium 23, relative atomic mass, oxygen 16 and hydrogen 1, 0.125 moles. But their mole ratio, here 2 mole, here 1 mole. That means number of mole of sodium sulfate is half of moles of sodium hydroxide, because their mole ratio 2:1. Sodium hydroxide ratio sodium sulfate 2:1. I mean 2 goes to 1. Sodium hydroxide goes to sodium sulfate. Sodium hydroxide is 2, sodium sulfate 1. Sodium sulfate mole is half of sodium hydroxide. Now moles of sodium sulfate, here this is the moles of sodium hydroxide, so 0.125 divided by 2. Why divided by 2? Because sodium sulfate mole is the half of moles of sodium hydroxide. We get 0.0625 moles. Now mass of sodium sulfate, number of mole times molar mass or molecular mass. Number of mole is here 0.0625, molar mass by adding all relative atomic mass sodium 2 atom 23 times 2, sulfur 1 atom, so only 32, oxygen 4 atom 16 times 4. If I calculate, we get these values. 8.875 gram of sodium sulfate will be produced. Okay, moles of sodium hydroxide mass divided by molecular mass, this value. So moles of sodium sulfate will be half of this. Moles of sodium sulfate, this value divided by 2, we get this value. Now mass of sodium sulfate, number of mole times molecular mass, we get this value, 8.875 gram. Now problem 7. Next problem is asking you, calculate the mass of water produced. Water mass, what when 4 gram of methane, CH4 is methane, is completely burned in oxygen. Here also methane mass is given as gram, so we will apply solid formula. Moles of methane, mass of methane divided by molar mass. Carbon 12, hydrogen 4, we get 0.25 mole. Now you see the methane and water mole ratio. Here methane 1 mole, water is the 2 mole. Water mole will be double of methane. Water mole are 2 times of methane because they are mole ratio 1:2. Methane ratio with water 1:2. I mean methane goes to water 2 times more, 1:2. So moles of water 0.25 times 2. 0.25 times 2 because moles of water twice of methane. We get 0.50 moles. Now mass of water equal number of moles times molar mass or molecular mass. Number of moles 0.05 and molar mass of water 18. Here H2O, water, hydrogen is 1 times 2 plus 16, 18. So now mass of water will be 9 gram. First, moles of methane mass divided by molar mass of methane, we get 0.025 mole. Methane mole to water mole 2 times more, so moles of water will be moles of methane times 2, we get 0.05. Then mass of water, number of moles time molar mass, if we multiply, we get 9 gram. 9 gram of water will be produced. Okay, this is your practice problems. You will solve it. Practice problem 1. Calculate the mass of water produced when 8 gram methane is completely burned in oxygen. So at first you find out moles of methane as methane mass is given. Moles of methane will be mass of methane divided by molecular mass of methane. After that you will calculate moles of water. 1 goes to 2. Moles of water will be double of moles of methane. So methane mole multiply by 2 times 2, you will get moles of water. After that, mass of water will be number of mole times molecular mass of water. You will get this value. Problem 2. What mass of sodium sulfate will be formed when 10 gram of sodium hydroxide, this is sodium hydroxide is 10 gram is given. So what mass of sodium sulfate will be produced? At first you will calculate moles of sodium hydroxide. 10 divided by molecular mass of mR of sodium hydroxide. You will get this mole. After that you will calculate moles of sodium sulfate. Sodium sulfate mole is half of sodium hydroxide. You will divide by 2, then you get moles of sodium sulfate. After getting moles of sodium sulfate, mass will be number of mole of sodium sulfate times molecular mass of sodium sulfate. You will get the mass of sodium sulfate produced. Problem 3. A 4.4 gram of potassium nitrate, KNO3 is potassium nitrate, heated strongly. Calculate the mass of potassium nitrite. KNO2 is the potassium nitrite produced. As 4.4 gram of potassium nitrate is given, first you will calculate number of moles of potassium nitrate equal mass in gram given 4.4 divided by molecular mass of KNO3. You will get moles of potassium nitrate. Then potassium nitrate to nitrite 2:1. If you divide by 2 moles of potassium nitrate, you will get moles of potassium nitrite. After getting moles of potassium nitrite, mass will be number of mole of potassium nitrite times molar mass of potassium nitrite. You will get the mass of potassium nitrite. Problem 4. This is the propane. Calculate the mass of water produced when 220 gram of propane burns completely in air. Calculate the mass of water produced when 220 gram of propane burns completely in oxygen. Propane mass is given. So you are asking mass of water how much? At first you will calculate moles of propane mass 220 divided by molar mass of propane. You will get mole of propane. After that, mole of water will be 4 times of moles of propane. because their ratio 1:4. Moles of water is 4 times of propane. After getting moles of water, you will get mass of water equal number of mole of water you calculated times molecular mass of water. Molecular mass of water is 18. How? Hydrogen 1 times 2 plus 16 equal 18 you will get. So thank you dear students. Please subscribe, like and share my channel with your friends. Thank you.